Okay, so today we're going to talk a little bit more about decoder installation. And so there's a few factors that go in when you're trying to select the best decoder to install in the different models. And so what I'm going to do is I'm going to go ahead and reposition the camera, and we're going to compare the two models. The first one, the SD40 that we've been working on, and a B23-7, just to kind of show you some various differences, even though most of the same things that we've done to date would actually apply to the B23-7 as well. But we're going to show you some instances, so if you're not necessarily doing the SD40, that you can see what it takes to do the decoder installation. So what I'm going to do is I'm going to go ahead and move the camera first and position it over my shoulder like I had been in the previous video, so you can see what I'm doing here in front of me, and then we'll go ahead and discuss and start the decoder installation. Now here laid out in front of me is a couple of Blunamis and a couple of current keepers. And when it comes to your decoder installation, you want to look and see what your installation is going to entail so you can pick the best decoder for the option. Now, this one up here in front is this B23-7 that I've been working on, and here's the body shell as I finish putting all the wires together inside the body shell. But I'm working on that also simultaneously. But you can see when I look at the chassis and I line them up here, you can see that they're very similar. We've got our motor, we've got our orange, and the black wire is back here for the motor. We've got our orange and gray wire for our motor here, and then we have our track pickup leads, and then these are our truck lights, ground lights, wires. We've got these magnet wires here, which are essentially our truck lights, ground lights on this model. So we're going to start by putting together the SD40, but you can see that while this is a very similar installation, you can see a very similar chassis, we're going to choose a slightly different option. So for our SD40, we're going to go ahead and use our Blunami PNP8. This is our 885613, and this decoder is a board format. It comes with the sounds for the EMD, which will give us the SD40 645 turbo sound file. But it also will fit right there on top of our model. And this is backwards, but you can kind of see it'll fit there right on top of our model, on top of the motor there. And then we can wire all the wires that we've done to this. Now, a couple of things on this particular one is it's not pre-regulated for LEDs. So if you have LEDs, you will need to use resistors. You can usually go to Amazon or DigiKey and you can get bulk packages of 1,000 ohm resistors. I think this was like $10 for 1,000 of them or something like that. So I've got plenty of resistors, but you'll want to make sure you have that. And the other thing is it also allows me to use various resistor values because, like, say for example, the ground lights or the truck lights are not going to be as bright as the headlight, and same with when it comes to things like the class lights and the number boards. You're not going to have those as bright as you would the headlights. And so we can use this and use different value of resistors so that way we can adjust the overall brilliance. Now on this particular model, this is the B23-7, you can see I've got a scale sound system speaker ready to go in that. In this particular instance, we're going to use the Decoder Buddy. And basically what I'm going to do is I'm going to mount it up here with some double stick tape, and then we're going to go ahead and wire everything to this. Now, the advantage to using the Decoder Buddy is that it does come pre-regulated with LEDs already on it. Or, I'm sorry, with resistors for the LEDs already on it. So you don't need to add any resistors. But the particular reason I'm using this one is that this particular speaker replaces the... So this had an A-frame speaker mount right here. And I chose to go with the scale sound system speakers, partially because our 30mm round is only rated for 0.5 of a watt. And even putting two of those in here in parallel really doesn't give me the full sound spectrum that I'm looking for. So I could get our 1-inch round, put a shim in here, and I've done some installation application notes where I've shown you how to do that. But I decided not to do that this particular time. And so I went and got the the replacement speaker from Scale Sound Systems. But part of the reason I chose that is because this is why the Buddy's going here, is because if I was to try to put the PNP board, and let's see if I can do this way, but you see the PNP board mounted on these tabs here would encroach where the speaker is at. And even, you know, even with this one right here, it would encroach into this area. And we have this weight up here towards the front, which is going to go under the cab and in the area up here. So a PNP board might be a little too long. And so for this particular decision, that's when I went with the NIX Decoder Buddy. And then we have a 21-pin Blunami for GE that we can just plug right into the Decoder Buddy once we put it in place. So now the other thing is you want to try to figure out how much space you have for speakers. Now, for the current keeper. Now on this particular one, the current keeper is going to live right here, back behind the speaker assembly. And we've talked about putting a current keeper here, and I have to actually do the measurements to make sure it'll fit. I haven't figured that out yet, but if not, I have a regular current keeper that might be able to lay on top of the circuit board. So we'll open it up, or we'll test fit and check everything out to make sure that it will work. But that gets some of the things to kind of keep in mind when you're trying to select the decoder that's going to best fit your model. And so you want to look at the overall design, how it's going to fit in there, and you know where all the wires are going to go, and how that's going to affect. And so that's why this particular PNP board wouldn't fit here, because you can see it encroaches, and if I go any farther forward to clear this, then it encroaches in this, and then you end up having to cut way too much. I did trim this down just a little bit. Not really for any major reason, I just want a little bit more clearance room behind the cab, so when my wires come through, I'm not working with tight space. But the PNP board wouldn't fit here without having to cut something, and you may have to cut this out, and then you're moving it forward to fit, but it's going to be a tight fit. It's just easier to put the buddy in place and just put it right there. And now I don't have to cut any weights, and it clears both sides, and then I can use our 21-pin decoder that'll plug right in. Now, as you guys know, I'm using all Blunami on all my personal locomotives. This really is the way to go. So if you haven't checked out Blunami, be sure to check out the videos we've done about Blunami, how much easier it is and fun to use, especially when you're running trains and doing all your sound selections and everything through the app. So okay, so what I'm going to do now that we've kind of discussed how to select which one is going to be best, what I'm going to do is we're going to take this out of the way, and I'll work on this one separately, but we're going to go ahead and get working on the SD40 so that way we can go ahead and put this all together and finish up our series. Now on this particular video here, I'm also going to use another scale sound system speaker. This one here is specifically designed to fit right over the rear gear tower here using their existing mounts. I have also done it where I have it up here, where you can use two of the mini cube speakers and build a little baffle, a styrene kind of a frame that holds these in place, and then can kind of come up here and then hold down with the screws. You can do that. I've done that on some of the models as well, so it really is kind of up to you what you want to do. But in this particular installation, I decided to use this one. And for those of you guys who don't know, Scale Sound Systems makes a series of small baffles. They're also a SoundTraxx retailer, so you can buy one-stop shopping. You can get your Scale Sound System speakers and SoundTraxx Tsunami 2 and Blunami decoders from him all at one place. So, okay, I'm going to clean this up, and then we're going to come back and start doing the decoder installation. Okay, we're here at the workbench, and we're getting ready to put this decoder in. And so we've identified we have our wires here for the truck leads or the ground lights down here. We have our track pickup wires front and back here. And then we have our motor wires. Now, first thing we need to make sure is that which side of the motor is positive, which side's negative. So we can take our battery, and we're going to connect minus to the bottom. And normally do this on a flat surface so that we can actually tell which way it's turning. So you can see that that is moving our model forward. So the orange wire is the V+. So we just want to double check and make sure. So now with that, we have our Blunami PNP8, and we can simply take the decoder out. Go ahead and cut the plastic here. Now, for those of you guys, when you're doing the installation, I highly recommend you open it up and read some of this stuff. It has wiring diagrams, things like that. That'll be important to know when you're actually doing the work on your decoders. I've obviously done one or two of these, so I don't necessarily need it, but for those of you guys who don't do this for a living, I would highly recommend it because, for example, there's a lot of stuff in here that says complete information is available on our website for all the work that you need to do on the decoder. This is just a very, very brief overview. I want to stress that again. This is a very, very brief overview. And so, for example, when you look at the horn list on here, there's only a handful that are listed. It's not the full complement. So you'll want to go to the website, or in this case with the Blunami, you'll use the app to see the full entire list. But be sure to check out the information there on the document. So let's get our foam over here and put the model on here. Now, we have our soldering iron hot and ready to go. We have our solder over here. We've got our flux. As you can see, I'm nearing the end. The good news is, right below the camera, I've got a whole fresh new tube of this, so when I run out, I'm good to go. So we're going to take our decoder, and you can see that the motor terminals are here. They're going to be on this side, so when we mount it, we're going to want these wires to go towards that side, which is already pre-planned. So what we're going to do is we're just going to take a small piece of this double stick foam tape. You want to measure probably approximately the length of this, where that looks good. So what we're going to do is we're going to take our double stick tape. We're going to lay it right here on top of the motor. You can see that was just about perfect. Good guess, George. Peel this up. And then we can mount our decoder. Now you want to try to center it, because remember, we're going to put our stay alive here and we put our speaker back here, so you'll want to kind of center it as much as you can. And just like that, everything mounts on there. So your decoder's mounted in place. So the first thing we want to do is, since the wires, we're going to move the body shell aside. Since the motor wires are the longest ones and they're right here, what we're going to do is go ahead and mount that. So we want to double check and make sure which one's motor plus, which one's motor minus. And since I forgot to pay attention to it, we can look at it here. And so motor plus is the front and motor minus is the rear. So what we're going to do is we're going to take our wires, approximate the size and length that we need, trim that, save that excess wire. And what we're going to do is we're going to strip the end of the wire. Now this is 28 gauge that I used on this. Then what we're going to do is we're going to tin the ends of the wire. So what we're going to do, just put a little bit of solder here on the ends of the wire. Now this one's already twisted up quite a bit. So we're going to put a little bit of flux there. Okay, and we're going to tin the end of the wire. So we're going to get our clean, fresh tip of the soldering iron, and we're going to get a little bit of solder on the end, and we're just going to touch the wire, and that flux is going to draw it into the wire itself. And there you go, just like that, we got our tinned ends. So this one was really long, the white wire, which is my motor minus. So we're going to nip the end of that. And then what we're going to do, we're going to first, I'm going to put some flux on here. And then what we're going to do is take the motor plus and stick it through. Now it's wanting to leave, so we're going to hold it in place. Grab some solder. And again, you want to make sure what's around you when you're doing your soldering. Let's put a little bit more. It's always easier to add a little bit more solder to these joints rather than, it's a whole lot harder to take it away. There we go. But you want proper coverage. And for those of you guys who are new to soldering, make sure you go back to our YouTube channel and watch Webinar 9, because Webinar 9 will teach you how to do all your soldering. All right, so we've got that in. Now what we can do is come in here and trim off any excess just using our pair of cutters. And then next we're going to take our motor minus terminal wire here, and we're basically going to do the same thing. Stick it up through the hole. Let's see. Oh, my fingers are not cooperating this moment. There we go. And that one's holding better. So now we can get the solder on the end. And it also helps to be ambidextrous when it comes to soldering, so that way you can get the soldering iron in at the right angle that you're looking for. And for whatever reason, I don't seem to be putting enough solder on the soldering iron here. There we go. There we go. That's a lot better. Okay. Again, we'll clean the tip, and we can come in and cut off any excess that's sticking up above. And again, cleanliness and neatness pays off. So in this case, we've got our wire coming up, and then this wire is the orange wire, which is our motor lead, motor plus. We can kind of tuck that in, and then when we're done, we can run a piece of tape across there. Now we're going to do the same thing for the front and rear track power. So we're going to go ahead and put some flux here on the ends, or on these terminals here. And we're going to measure here. Now when we're doing the front, remember we have the cab interior that we installed, and we want to make sure that this goes in underneath and up and into this properly. So you want to make sure that you have enough wire. So save your excess wire. You never know when you're going to need it. Okay, and you're going to notice a repetition here. We're basically going to be doing the same things, and I'm going to kind of use this as a guide. Because they're basically going to the same place, just opposite sides of the model. There we go. And so what we're going to do is we're going to get our flux on here on the end, and we're going to tin it. Now one thing you want to do is you want to twist these wires to make sure that they're twisted together tight. So the point of tinning it is to make sure there's no frayed wires. Your knot wire isn't coming in like this. It's all nice and tight, so that when the solder comes in, it also primes it. So when you make your solder connection to the decoder, the solder flows a little bit better too. So we're going to go ahead and tin the end of this one. Grab this, and we're going to tin the end of this wire. There we go. Alright, now we're going to wrap this around, and doesn't need to be perfectly routed right this second, as long as we know left rail, right rail, and we want to make the solder connection. Well, this one too seems like it's wanting to jump around, so let's go ahead and get some solder on the iron, and we're going to go ahead and solder this one in place. There we go. Okay. And again, we can trim back the excess. There's a little too much on that one, but it'll be okay for this particular joint. Okay, we're going to do the same thing on the other side here. Now when you're doing this front to rear, you want to make sure left and right rail are soldered properly. In the grand, oh, I've already got flux on there. In the grand scheme of things, with DCC, and especially in the case here of the Blunami, track polarity really doesn't matter. The biggest important thing is to make sure your truck or your motor wires are proper polarity, because when the decoder sees forward, it's going to turn the motor plus as the plus and turn the motor the proper way. Because in DCC, if I pick up the model and turn it around, my track polarity is now reversed. However, if you're going to be using this in a DC control environment where the DC track power dictates the direction, then absolutely you want to make sure left rail and right rail are properly soldered. But in this case, when I'm doing most of my models, since I'm using them in DCC, And even if I go to a DC layout, the Blunami dictates the direction. So track power is become, again, irrelevant. So that's one of the things, a little tip for you to keep in mind. But honestly, it's probably a good practice to do it right, but we can get away with a little bit more than what you think. All right, there's our track power leads, and they're coming in here below where our current keeper is going to sit. Now we're going to do the same thing here on the back. I'm going to turn this around, and I have these wires coming from these magnet wires coming from our ground truck lights. So again, you want to pay attention to where those are. Just trying to make sure that they're properly handled and not just tossed aside, because magnet wire can be fragile. So all I'll say is experience tells me be careful with it, and you should be okay. All right, there's our rear truck wires. Again, we're going to make sure these are twisted together. This one, for whatever reason, just wants to fray, but I finally got it. Okay, so again, put a little flux on these. That one bent for whatever reason, but we're good. There we go. We've got our flux on our joints. Now again, we're going to take a little bit of the solder. We're going to touch the wire. That one's tinned. That one's tinned. All right, now we're just gonna, now again, remember, right rail, or in this case left rail goes to the front and back on the same side. If you cross this for whatever reason, you could end up with a direct short, causing all kinds of problems down the line. So you want to be careful to make sure that your track wires are going where you want them to. Now in this case, again, I've already got the flux on there. Go ahead and solder this one in place. Whoops. If I can get my fingers to cooperate with me. Well, again, for whatever reason, I seem to not be able to put enough solder on here. There we go. Okay, there we go. There's a nice joint. Again, trim the excess, and then we'll route the wire down through when I'm done. So we're going to take this wire, put it up through. That one's holding well. And there we go. So there's our track power, our motor wires, and everything soldered in place. So now we'll just route these wires around where our speaker's going to mount and get it ready. So there we go. Now before I do anything with the lights, you can test it at this moment in time. You can test track polarity. Make sure you have everything working proper. Over here in the corner, it's kind of hard to see in that camera angle, but I have a DC power pack that I can power up a piece of track with, or as you guys have seen in one of my past YouTube videos, you can use a 9-volt battery to test it. Personal choice if you want to test it or not. But I think the next thing what I want to do is I want to put the speaker in place, and whoops, if I can get my fingers to cooperate. And if you remember, we're doing this Athearn SD40-2 speaker from Scale Sound Systems. And so, as you can see, I've got the screws mounted right here. The good news is this literally mounts on here just like this. And you can kind of see how much space we have too. And then the other benefit is that the speaker terminals are here on top. So what we can do is we can mount this in place. So what I'm going to do is I'm going to get my Phillips head screwdriver. Now these are the screws that we used to remove the weight if you remember back in episode 1, that holds this weight in place inside the model. And so this will set up here. Oops. All right, there's the screw going into there to number 2. All right, there we go. Speakers installed. Nice and easy, right? So now what we can do is we will take some of these scrap wires, and I happen to have 2 of them right here, a red and a black wire. You can use purple wire. We do sell wire by 10-foot rolls of it on our website and through our retailers. I'm just reusing these here, and what I'm going to do is simply solder to these terminals here and then to the speaker plus and minus terminal right there. Pretty quick and easy. Where's my flux? So we can just put it in here like that. Now this is where your tweezers are going to come in handy, because you can hold the wire while you're doing this. Now these wires have been pre-tinned, so I don't need to do much to them except hold them in place. We'll put the red wire on this side, and it ultimately doesn't really matter whatsoever. Okay, there's the red wire, and here's my black wire. And in this case, my black wire piece was a little shorter, so that's why I chose to mount that one closer to the speaker terminals on the decoder itself. So I come in here. Now, of note, if you are soldering to the speaker wires before you mount it to the model, make sure you hold this magnet on the back of the speaker down somehow. I usually use a tool to hold it down, because the magnet will jump up and magnetize itself to the soldering iron. So just have to be careful with that. So now these wires can come in here. They'll be cut about an inch shorter than they were, and we're going to strip the ends. Now you can route these wires however you feel comfortable. You could go under the decoder and over to the speaker plus and speaker minus terminal. It's entirely up to you, so that they're out of the way. I'm just going to mount them here to the top, because ultimately, like I said, it doesn't matter, and it's right there on top. Alright, so we're going to take this off of my rubber healing mat and get a little solder on the end, just like that. Now, whoops, let's change hands. And so now I'm going to take this black wire and solder it to this terminal. Now when you're using one speaker, the speaker polarity ultimately doesn't matter. But if you're using 2 speakers, you want to make sure that you pick one of the terminals to be plus and one to be minus, and be consistent. So we're going to go ahead and put this in here. There we go. Oops, that didn't take for whatever reason. Come on. Come on, wire, go to your home. Are you too good to go to your home? Tell me if you know in the comments if you know what that's a reference to. There we go. All right. So again, what I'm going to do is I'm going to take my clippers here, and you can see where the wires have come through on the underside. And I'm just going to clip these short. Oops, that piece of wire stuck to the tape. Where are my tweezers? Let's get that piece of wire away. And the idea is that you want to make sure that your wires are not going to possibly interfere with anything else. So with these solder joints made, you can actually test the model now. We can put it on a piece of track. We have motor, we have track power, and we have a speaker. So we can test that, and we can do that. Now, before I do, I'm going to test it off camera just to make sure everything's good to go. Also because I just noticed my camera, this camera is low on battery. So I'm going to pause right here, and then the next section we'll get into adding all the lights and wiring them up to the decoder. But we've talked about, we've got our V+ terminals here all together, ready to go. So it should be a pretty quick, easy installation from here on out. But for this, I'm going to pause the camera, go recharge it, and then we'll be back. Okay guys, we're back here. I've got a charged battery, so we should be good to go for a little while. And we're going to go ahead and start adding in the lights. Now you're going to notice this installation is going to be pretty quick and easy because we've done a lot of the preparation. So the only thing left that we're going to need to do is we're going to need to grab some resistors, because the PNP board is not pre-regulated for LEDs. Okay, I had to find my resistors. I've got my 3.3K and I've got my 1K. The 1K I'm going to use for my headlight and backup light, and then the 3.3K I'm going to use for the other lights, such as the ground lights, the class lights, number boards, those things, because the 3.3 will actually give me a little bit dimmer of a brilliance rather than having to use the 1K and then adjust it. We can do that with CVs, but we're going to go ahead and do it with a little bit of resistors as well. But as I was saying, that the PNP board is not pre-regulated for LEDs as indicated in the document that comes on the card that I told you guys to make sure you pay attention to. And this way you're fully familiar with what the decoder can do, how to wire it, and so forth. Now, personally, I prefer to do the resistors because this gives me a little bit of ability to have some autonomy over the adjustments. Because I can use, as I'm saying here, a higher value resistor, so I can get a little bit dimmer of a light rather than being, you know, a 1K all the way around. And yes, our decoders do have the ability to make adjustments to the brilliance. I just like using the 3.3K because it gives me a little bit more. I can dim it down a little bit further than what we had. Now these are just packs you can get at DigiKey. Or you can even get some of these on Amazon. You can buy them a whole bunch at a time. We're just going to set that aside. So with what I've got is I've grabbed 6 of these, even though we're only going to use 5, and I grabbed 2 of these. Now the other thing we're going to need is heat shrink tubing. Now one of the things I have is a big stack of small pre-cut pieces of heat shrink tubing that you can use. And we're going to use this at various sizes and lengths, but it really isn't difficult to do it. It's just it takes an extra step, which isn't necessarily difficult. It just means you got to pay a little bit further attention. So we've got our 3.3, we've got our 1K, we've got our heat shrink tubing, we have our LED tester, and the LED tester is going to allow us to test the lights to make sure we're connecting them to the proper locations. We have our wire cutters so we can cut them short, our tweezers, and that should take care of it. Now over here off to the side I've got my flux, whoops, I keep hitting the camera, and my wire strippers. So all of this is going to be used during this installation. Now in part 3 I talked about how we use the wire or the LED tester, and basically what we're going to do is we're going to go ahead and make sure that these parts of the wire, we're going to make sure our truck lights work. So we're going to take these, and I'm going to show you how to work with magnet wire. Some people may not be familiar with it, but in this case this is a darker red. That's our V+, and then the lighter color is more of a copper color. That's going to be our V-, and we are going to want to make sure, and again we're testing these just to make sure they still work and make sure there's no problems, because it's a whole lot easier to fix a problem now than it is when you're testing it out and you find out that a light doesn't work. So we're going to go ahead and touch this, and you can see our truck lights are now working on one side, and then there's the other truck lights. So you can see our truck lights, ground lights, they are working. So we can disconnect. Now, what I like to do on this particular one is I like to run these on the underside. And the reason for that is because that way it minimizes the amount of stuff here on top. So what we're going to do is actually I'm going to route this a little bit differently over here. I'm going to take this side and I'm going to route it above my track power wires over here, and I'm going to do the same thing for the V plus side of this. And the reason is again, we're trying to make sure that none of this gets into the mechanism, but we've already got these truck wires in place, and these two come out of the nearby ones. So then what we're going to do is we're going to take our two light copper color, we're going to pull them out, and then what we want to do is we want to kind of start twisting them together a little bit so that they are kind of together. Let's get these out of the way. Now, one of the things I haven't shown you yet, and we're about to do this, is you can get a whole bunch of these self-closing tweezers like this, and what this does is this helps hold things like wires out of the way, which is what we want to do right now. So we've got this, we're twisting this together to make sure it's together, and then we're going to go over along the side here. Now these ground wires, or ground lights on this particular decoder, I like to wire to the FX7, which is right here. So what we're going to do is we're going to take this in such a way, and now that they're kind of twisted together, what we're going to do is we're going to find just twist them together. It doesn't mean it has to be super tight, but by twisting it together, what we're doing is we're making sure that the wires are together. And in order to work with the magnet wire has a thin varnish coat over it, and that's what insulates it, and that's why it looks shiny, because it's metal, but it is still the bare metal underneath the varnish. Now what we're going to do is we're going to go ahead and pinch off about here, and we'll give ourselves a little bit. So we're going to go ahead and cut that. Now this excess magnet wire, if you want to keep it, you can keep it. I personally don't. It's going in the trash. Now we're going to go ahead and turn on our soldering iron, and when you're working with magnet wire, you have to basically clean the varnish off of the end of the wire. And actually this looks a little long. Let's go ahead and cut it about there. So we'll cut it a little bit shorter. And if I can get my fingers to cooperate, what we're going to do is we're going to put a little bit of flux here on the end of the wire. And what we're trying to do is we're going to burn off or melt off the varnish. So in order to do that, we've got our soldering iron. And what we're going to do is we're going to put a little bit of solder on the end of this. Come on. Now I just turned it on, so it takes a minute to get warm. There we go. And in this case, you can put a little bit more of a blob on the end of the soldering iron, because we need to melt through the varnish on here. And we're just going to take the end of this wire and we're going to stick it in the melted solder, and that's going to kind of burn off and clean off the varnish. And you'll get to notice that when you're done and when it's finished, you'll notice that the wires will look silvery as opposed to bronze or gold colored, and that's your indication to let you know that the solder is actually sticking to the wire now, and it's not being repelled by the varnish. Just takes a few minutes or a few seconds, and this looks pretty good. Just gonna make sure we got enough there. Okay, looks good. And I know it's hard to tell on camera, but we can always test it. So again, this is where the testing comes into play. So we're going to put our LED tester here on the end of that, and these wires apparently decided to separate. So we're going to retwist the copper ends of this together to make sure that when we touch the white wire or the red wire to this, that they're both going to get contact. All right, and there we go. Whoops, one wire apparently fell out. Apparently they weren't twisted together very well. Oh look, no, one wire broke. Well, okay, let's twist these together. We're going to be cutting this one short anyway, so ultimately it doesn't really matter. We just have to make sure that we have enough of the bare wire, the exposed wire, to touch when we do the test, so that way we can tell. Alright, so there's that one. There's that, and you can see, whoops, the black wire broke off, the black wire fell off. Okay, so now you can see we got one lit and we got them both lit. So we know that this magnetic wire, or magnet wire over here, let's grab this and move that aside. So we know that this solder joint is good on the end of the wire. So now we can take our 3K resistor, and what we're going to do is we're going to take a little bit of heat shrink tubing, and these are cut to about 1 inch. You don't necessarily need them that long. I like to go about a 1/2 inch or so. And what we're going to do is we're just going to slide this over the end. Again, we want to make sure we insulate as much as we possibly can. Now when it comes to the resistor, we're going to cut this lead short because we don't need to solder to it all the way at the end. We want to make sure we shorten these leads. So now what we're going to do, and get our flux, we're going to put a little bit of flux here on the end. We're going to take our tweezers. Now I think there's still some solder here on the end. It's probably going to work okay. And what we can do is then we just solder these together. And there we go. And now that's soldered together. And then what we're going to do is we're going to take the heat shrink tubing, we're going to slide over the joint here, over the end of the resistor, and now all that's insulated. And remember, this magnet wire is insulated. So we're going to go to the FX7 over here. So what I'm going to do is I'm going to put a little flux on the joint. We're going to bend this resistor lead up, if I can get my fingers to cooperate with me, just like that. And we can actually cut this short beforehand because we don't need to push that whole thing all the way up and through the connection. But we can come up here just like that, and we can hold that about there. Let's get some solder on some fresh solder on the end of this. And go ahead and make our joint. Oh, come on. Now, you'll notice I'm actually soldering it out a little bit so it's not flush underneath. The reason for that is because I still have to solder all these. So if I put this immediately underneath, then I don't have access to it. So, and then, then we'll trim the excess. Nice, clean, professional joint right there. Now we're going to add the rest of the lights. So go ahead and move my resistors out of the way, because what we want to do is bring this Locomotive body shell over, and this is where we're going to check all these lights to make sure which ones are which. So on the front, we've got all the wires coming here, so we can use our LED tester, grip it on the red, and then we can use the black lead to test all these wires and figure out which is what. So when I connect here, let's see what lights up. Those are the front number boards. You can see that. So on my personal wiring diagram, I like to go headlight on front and rear, of course. Then FX3 is my front class lights. FX4 is my rear class lights. FX5 are the front number boards. FX6 are the rear number boards. And then FX7 is, as we talked about, for the truck lights. Now, once you find these things out, if you want to separate them, you can simply grab some more self-closing tweezers and test these wires as you go. So then we're going to grab the next pair of wires, and let's see what lights up here. These are probably going to be the headlight, and that they are. So those will be the headlight. And then by process of elimination, that means these last ones over here, this last pair of wires is my FX3 for my front class lights. So I'm going to start with the headlights. And we have our wires. They're just kind of twisted together right there. But what we're going to do is we're going to grab our heat shrink tubing. We're going to slide it over the wire here. Now I haven't soldered these together. Now this next step is a personal thing. I like to twist the wire around the lead because it also helps more with a physical bond, not just the chemical from the flux, or from the solder, I mean. So when that's twisted around there, we'll put some flux on the joint, and I'm going to grip this with my tweezers. I'm going to solder it on here. Just like that. Now, you'll notice the wire's soldered here, but I have all this excess there. Length, we're going to cut that off. And so use your wire and your solder point as your guide. And so that way you don't basically lose the resistor. Now we're going to take our heat shrink tubing. And again, we're going to slide it over the resistor. And so it's usually a good idea. I like to use 8th watt or 6th watt resistors because they tend to be small and they fit in my heat shrink tubing. Really up to you. Now, a lot of times you've seen me do the heat shrink tubing with the barrel, and you can certainly do that just like that. If you're quick and careful about it, you can also use a lighter and just kind of flash it under there, because remember, you don't want to burn this and melt it off. We're just trying to shrink it. Just a cheap lighter you can get. Now what I'm going to do is I'm going to take this, and again what we're going to do is just bend the lead, cut it short. Now this time we're going to solder to the top of the board, so don't need too much. Now one of the other things to point out is on the end of this decoder, you'll notice that there's the two center ones are for your headlight. One's your function common, one is your lighting output, but which is which? If you look closely, one of them has a rectangular gold colored soldering pad. The other, if you look closely, is oval shaped. And so the oval shaped indicates your function common, not your lighting output. The lighting output is the rectangular one. So this would be the headlight output. This is my function common, and this is what all the red wires and these red wires over here, wherever they're at, there they are going to go to, is this function common here. So when I grab my headlight resistor here, and we can actually come backwards over this because it ultimately doesn't matter. We're going to put our flux on the end of the joint there, and then let me grab the soldering iron and get some more solder on the end of this. Now I'm going to change hands, and what I'm going to do is I'm going to hold this in place, and then we're just going to come in here and solder it just like that. Now the headlight's attached. Now we can always test it by taking our resistor 9-volt battery and touching the end and making sure the headlight lights, and it is, so we are good to go in that regard. So next up, we can do our class lights, which are this one right here. And I'm going to grab my 3.3K resistor, and we're going to do the same thing. So now I'm going to get my heat shrink tubing, cut a 1/2-inch piece over it. I'm going to slide it over the wire. Yep, my fingers are not cooperating very well. There they go. All right. So now, again, we're going to take the wire, kind of carefully wrap it around the lead of the resistor. Like I said, this is me personally doing this. I like to make sure that it's going to make a solid connection. There's been times, like if I don't wrap it around when I solder it, and then when I shrink the tubing, the heat shrink tubing, actually the heating up of the heat shrink tubing actually loosens the solder because it hasn't completely cooled from the last solder job, and can make it loose. So now there's a physical wire wrapped around the lead. I just like it. It gives me that extra confidence to know that it's connected. But there's certainly not necessarily a wrong way to do it. You just want to make sure that A, you're using the proper flux, and B, you're making sure that to insulate and protect the joint. But after that, whether you solder the wire to the side of the lead or wrap it around like I did, 6 of one, a dozen of the other. Now you're going to see I'm going to use the lighter just as a really quick heat shrink. So again, pick your poison. You have to be really careful with that though, because you don't want to overheat. And so now what I'm going to do is I'm going to bend the wire here, because now we're going to go, this is the class lights. So we're going to take this to the FX3 lighting output, which is right here. And again, pay attention to your wiring diagram, because that's going to tell you everything you need to know. And we're going to go ahead and I'm going to move this. There we go. Let's get some solder on the end. And what we're going to do is we're going to come through here. All right, solder's in. We can mount that flush, and then anything that comes through we can trim off, make sure that it's clean and out of the way, and you've got your joint. Now I'm going to show you how to do the function commons, and the rest of these are just wiring them up where they're convenient or where you want them to. There's no right way or wrong way. In other words, FX3 can be reassigned for anything. If you wanted FX3 as your number boards, FX4 as your front class lights, FX5 as your rear number boards, FX6 as your rear class lights. However you want to do it, it really doesn't matter, because remember, every one of our lighting effects are programmable, so you can change them to do whatever you like. So you're not forced to do one or the other. But I'm going to show you really quickly how I do these function commons. So here we're going to go ahead and add in these. So what we want to do is we want to have these come together, and what we're going to do is we're going to do the same thing we did with the function output for the truck lights. We're going to kind of twist these together. We're going to make sure we have a little bit of a wire that will give us some function common here, and you can twist it a little longer than what's needed, and we're just going to go ahead and trim that right there. And as I said before, I do throw that extra magnet wire away. And here's a little personal trivia for you. I don't trust magnet wire, but in order to do some of these lighting effects, they're kind of necessary, so we manage. Okay, so now what we're going to do, we're going to do the same thing we did with our function common. Is we're just going to take this and we're going to set this into the solder. We're going to try to clean off that varnish insulation. And I will tell you, there's certainly different classes of magnet wire, so some are certainly better than others. But my personal disdain or lack of trust for it was years and years ago. I had done magnet wire in a model where I had changed out the headlight for a micro LED. This was when they were first popping on the scene. And what happened was the magnet wire apparently became nicked on two places, and I was running it between a split frame on a steam engine, and it touched both sides of the frame, which was carrying track power, which meant it created a direct short. So the magnet wire got extremely bright as it was burning, and let out a little bit of smoke, which of course I panicked. And when I took it apart and found that out, I needless to say replaced it with some regular wires, some insulated wires. So I've always had a, lack of a better term, a distrust of magnet wire, but we use it. So, okay, so that's good. And so what I'm going to do is, this is my function common. So in this case, because I'm on the underside, what I want to do is I'm going to stick this up through and kind of bend it over, because this batch of wires, which is over here, this batch of wires is about to go through there as well. So what I'm going to do is I'm going to tin the end of this wire, because I don't think I ever soldered this. So we're going to go ahead and tin the end of this mass of red wire. So that it goes through the hole cleanly. And all of these wires are connected, which we've already shown they are, but now they're soldered together. And so what we can do is we can trim the tip of this off. And then now our magnet wire is folded over the connection. So we're going to take this and put it into the hole, so that now the magnet wire and our red lights, our red wires for the lights, are all there. We're going to put a little bit of flux on the end of that. And then we're going to basically do the same thing. We're going to solder this. So just going to come in here. And just like that, everything's working. So everything's soldered together. So now you can see I've got my red wires going to the function common, and this is the overhanging here a little bit, so we can trim a little bit of this excess wire off. Get it out of the way. And then we have our red wire in here as well. So at this moment, you can put it on the track. Again, take your 9-volt battery and test it and make sure everything is lighting up the way you want it to. I would do the class or the number boards first. So let's get my heat shrink tubing. We're going to slide this over. Grab our resistor. And this is where it pays for proper preparation. So if you've prepped your Loco properly, like we showed you in part 3, this will really help make this process a lot easier, because everything's already organized, separated, and easy to find. So we got our flux. You see a lot of the same type of thing in these. Just like that. Now what we're going to do is trim off the excess, because neatness counts a lot in your installations. You want to make sure that your installations are clean, because if your installation isn't clean, it's leading to problems. So take your time, make sure you're doing this part properly, and slide your, oh, what do I got going on here? I got a solder dimple or whatever right there. So let's fix that real quick. There we go. I had a little dimple from the solder that looked like a shark fin, and it wasn't allowing the heat shrink tubing to slide over it without trying to cut it or tear it. Come on. There we go. So now we've got our insulation. Again, this time I'm going to use the barrel of my soldering iron. You can see how easy this is. Quick and easy. And one of the things, you don't want to use the tip, because your tip of the soldering iron is where all your solder is. And this has oil and such inside the shrink tubing that you don't want to get on your tip of the soldering iron, because then you can potentially run the risk of getting oil on there, and then your solder won't flow properly. So this is going on the FX5. So we're going to grab my tweezers here. Oops. Let's take that off of the cutting mat. There we go. Okay, so now we're going to come in here. So there we go. Now we've got the front lights wired in, and we can certainly test it by putting it on the track, turning on the Bluetooth, connecting to it, and doing your light connections. So I'm going to go ahead and finish this up. I'm going to go ahead and grab the rear headlight, the rear class lights, and the rear number boards. I'm going to make these connections off camera, because otherwise it's just 6 more connections, or 3 more connections, I guess, 4 more, whatever, of the same type of thing we just showed you. So rather than make you sit and watch each one of these, I'm going to go ahead and pause the cameras and come back with everything connected, and we'll show you how we add in the current keeper and button this thing up. Be back. Okay, so I've got all my wires connected, as you can see. Couple of things to note. Number one is I apparently had grabbed the wrong speaker. I went to test fit, make sure everything fit on there, and that original speaker that I had was a little too tall, and it wouldn't allow the body shell on by like that much. So unfortunately I had to change it out. I realized which one I grabbed the wrong one, so I've got another one here in its place. Full disclosure, so that way if you notice that the speaker looks different, that's why. So it's wired in place. Now the other problem I ran into is when we're testing our current keeper here, I don't think I'm going to have enough space for this current keeper here, because when this dropped down, what happens is now this can't fit sideways, and this is not going to clear this right here, which is where the back of our cab is at. It's close, but it's too wide to fit. Now the other side of the equation is this current keeper. Whoops, wrong knife. When I put this current keeper over here, what I'm afraid of is this may not have enough room on top of this to set in here. Well, it might. Let's try it. So let's take that one, set it aside. This may have enough room here, in which case if it does, then that's going to be a bonus for all of us. Let's go ahead and take these wires off to the side. Alright, what I'm going to do is I'm going to tape this down. Now many of you guys have asked prior why our current keeper plug mounts out to the side. And the reality of the reason for that is that when the current keeper needs to be plugged in and unplugged, if it was mounting parallel to this, then if you had to unplug it, there's a greater than 0 chance you can damage some of the parts that are on there. It could cause issues like that. So we don't want to have you damaging the decoder just by simply taking the current keeper on and off, or in and out, whatever you want to call it. So what we decided was that we would mount that sideways, so that way everything fits in there nice and neat. So let's check this out. Let's make sure this works first. And oh, it looks like we're just shy. So it is going to be a little too tall to fit this in. And that's kind of what I suspected, given the fact that the other speaker was too tall. So question is, how do we solve that? Well, let's take this back off and get our current keeper out of here. So the question is, how do we solve that? Well, here's what we're going to do. Remember, there's more than one way to skin a cat, which always makes me wonder, why are we skinning cats? And second of all, why do we need more than one way to do it? Anyway, philosophical moment. So anyway, now our question is, how do we put a stay alive in here? Well, our good friends at Nick's Trains, Nick Santos, sent me this. This is a Power Bridge 2-wire stay alive. And what this does is this will allow us to maybe tighten it in and fit there. So what we're going to do is we're going to take our Kapton tape again, if I can find the beginning of it. There it is. And I'm going to put a small layer of insulative tape across the top here, just like this. And because this is exposed electrical components, and let's not take a chance, right? So what we're going to do is we got to follow this instruction. So the black and red wire are going to go to our current keeper plug. Now, luckily for us, whoops. Let's see, surely I have one. Yep, I've got one that I've taken off of something else where I've used some other stay alive capacitors, stuff like that, because I have a, you can kind of see here, I have a bin of different types of capacitors and stuff like that that you can use for stay alive. So I've got this extra half of one here. So then we'll take this and put this back off to the side. And let's go ahead and open this up. Instructions. Both capacitors must be used for the power bridge to work. And we're basically, if you follow this instructions, the capacitors are being wired in series from one to the other and then back. And then the red and the black wire go back to the decoder. So we're going to pull this out of here. And to start, what we can do, again, let's keep our instructions handy. So we're going to put these right there on the edge. So we're going to find the V plus and the V minus side of these capacitors. And you'll notice that the V minus side has the stripe. So what I'm going to do on this first one is I'm going to take this and bend that to the side. Now on this one, we've got our V plus. Now the V minus is this one, so we're going to take this one and bend it off to the side. And what we're going to do is we're going to put these side by side and we're going to basically solder those together. That's simple. So we're going to get a one of these tweezers here to hold these together. And then when we're soldered, then we're going to take the excess and just cut it off. So it takes a little bit of coordination to make sure these are where you want them. And you want to make sure that these wires are touching that we're supposed to solder together. So we're going to simply do it just like that. I'm going to show you how quick this is. Okay, we've got everything where we want it. We've got our soldering iron hot and ready to go. So what we're going to do is put a little bit of solder on the end of this iron. And then we're just going to come in here, touch that. Now those two parts are soldered together. Just like that. Now we're going to come in with our cutters, which are over here, and we're going to trim off the excess for each of these leads. There's one. There's two. Done. You can see how easy that was. So now we're going to take our wires off of this. Now remember, the black wire is going to go to, what is this? I don't know what that is. Okay, the black wire is going to go to the V minus side, which again, we've identified this as the V minus. So what we're going to do is we're going to get our insulative tubing. Now these we can cut even shorter because we don't need that much insulation, because we're going to cut these leads down pretty high, or pretty short. So we're going to take our black wire, put the insulative the insulation on there. Now we're going to cut this down probably about like that. That's probably a good, hopefully you guys can see that. I think that's going to be a good length. It's about 1/4 of an inch. And again, what we're going to do is we're going to take our trusty our tweezers here. Now these wires don't need to be this long, obviously, so we can shorten them up a little bit. I'm probably going to make it about 1 inch long or so, because really don't need that much. And grab our wire strippers, and again, we don't need very much. So what we're going to do is I'm going to put a little bit of flux here on the component, on the capacitor, and then I'm going to do the same thing here. I'm going to twist this wire to make sure it's not frayed or anything like that. No loose strands. And what we're going to do first is we're going to tin the end of this wire with our soldering iron. Okay, now we're going to come over here, and with the solder on it, and there we go. And then we can do the same thing for the other wire. Cut it about an inch or so short. Strip and tin the end of the wire. Just like that. Now, do the same thing. Twist our wire to make sure there's no frayed edge, no loose strands. Come on. There we go. Alright, so now what we're going to do is tin the end of that wire. Now in this particular case you can see that the wire cut back a little bit, but we're going to trim off the end because we don't want a whole lot of exposed wire. We just need a little bit. Alright, now we're going to put our heat shrink tubing over it. And again we're going to cut this other side. I didn't do it beforehand on the last, like I did the last time. Put our flux on it, and then now we're going to take our brown wire to the V plus side of these capacitors. Now you want to make sure you follow this direction very, very carefully, because if you wire these in backwards, they can go poof. There we go, just like that. So now we have our our brown and our black wire attached to this, and this can just sit on top of here like this and go right there on the side. So let's shrink this heat shrink tubing. I'm on camera, I'm going to do this the proper way. Ha 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 ha. Okay. Again, we want to make sure that these are properly insulated. Then what we can do is we can actually twist the wires if we so choose. And then you can we could tape this up just like this. We're going to put some tape on. I'm just going to make sure, yeah, that's plenty. So what I'm going to do is I'm going to do exactly that. Put a little bit of tape around it and just to hold it together. Doesn't need a lot. And I wouldn't recommend going around and around and around it multiple times. What I'm just doing is putting one loop around it here to kind of hold it in place. Hold it together just like that. So there's our little Stay Alive module that we built from Nick's Trains. Now we have to get to our current keeper plug. So what we're going to do is, since we're mounting this up here, what we're going to do is we're going to connect these. So I'm going to go ahead and cut this about there. And in this case, we're going to go ahead and go wire to wire. So I'm going to go a little bit longer than I normally would be stripping stripping the wire. Okay, and we're going to do the same thing here. Now we're going to get our heat shrink tubing over here, and it doesn't matter which side you put it on. It really doesn't. Just make sure you put on the heat shrink tubing before you make your solder joint. Alright, now blue is positive on our current keeper connector, black is negative, and on Nick's thing here the black wire is negative and the red wire is the V+. So what I'm going to do is I'm going to take these wires here and I'm going to twist them together. Again, going along that same personal like to have these wires physically connected as well as soldered, so that way you have some sort of a physical bond that they're twisted together. The solder is an insulation, or is a insurance to make sure that the connections are made. So just like that, we've got our 2 wire connections made. We're going to put our flux on both of these joints, and just like that, we're about to solder these in. So we put the solder on one and solder on the other. All right, 2 perfectly soldered joints. Now we can trim this short because we don't need all of this exposed. Now what we can do, we're going to take our heat shrink tubing, and one of these wires is going to get folded back. We'll fold the NICS wire back, and we're going to come and put the heat shrink tubing over the connection. Come on, there we go. So I'll show you this again. We're going to take the insulation and put it over the joint, because again, we want to make sure these are perfectly covered, so that we don't have any problems at all with shorts or anything else touching the wires. So we're going to get our soldering iron over here and do the heat shrink. Okay, and just like that, there's our stay alive module using NICS new power bridge, because unfortunately our current keeper won't fit in this particular one. So now all we do is plug it in just like that, and then now I'm going to go ahead, we're going to do this. I'm going to put a piece of double-sided tape to hold this in place. So we're going to get our tape, cut a small piece of it, lay it right there, peel the tape up, and then we can mount this on here just like that. And then now you can take this wire and we're going to route it along the top of the edge here. Alright, so everything's installed. So we're going to take our body shell, and this is where you want to make sure all your wires get tucked in the body. Nothing's worse than finding loose wires sticking out of the bottom here when you're done. Like that. You can see I've got a wire coming down here that needs to be up inside. Come on, wire. Go inside. And these wires need to go up inside. There we go. It just takes a little practice to know what you're looking for. And now our body shell fits perfectly. So now it's time to button it up and put the couplers on, and then take it for a test spin. So I'm going to pause the camera for a moment, clean up my work over here. And there was one thing I did forget to do at this moment in time, which was to paint the inside of the rear number boards. Because the rear number boards, as you can see inside, are still wet, and I didn't realize I forgot to do this. So I'm going to let that dry, paint over it black so that we don't have the light leaking in under these fans. And that's something you can do. Another thing you can do, you'll notice there's a corner cut out of this foam piece over here, because you can cut these box foams. I'm using it right now as a space to work on. What is that? I don't know. Anyway, you can also use this as a light diffuser. What you can do is take a small piece of this, and I'm just gonna, using a fresh knife, come in here, cut it. And what you can do is you can actually tuck this up and inside, so that way it helps diffuse any light you may have inside your model that might be leaking through the fans or anything like that. And the foam also allows the sound to escape. So I'm going to make another one here. And this one is going to go up under the exhaust port, because that way, with our decoder's lights, the blue pilot light and such, that way it'll help diffuse it, so that way it's not a blaring blue light coming in out from under the shell. Now when you're doing that, I normally will tack it in place, so I'll probably do that quickly off camera. But what it does, it allows you to still be able to see it without a direct blinding blue light coming out. Now, before you ask, the blue light is there as a pilot light. It helps us know the track power is applied. And why do we want to know the track power is applied? Well, because if the track power is applied and the decoder's not working, now we know that there's something wrong with the decoder or our wiring or something. But if the blue light's off and the decoder's not working, well, that's because we know now that the track power is not getting to the decoder. So anyway, I'm going to go ahead and let this dry. It is late at night on a Saturday night right now, so I'm going to let this dry overnight. I'm going to paint it tomorrow, and then we'll take this thing for a test drive. We'll button it up and set up some basic programming CVs and setting up using the Blunami and the Bluetooth, so that way we can make it sound like an SD40-2. We'll take a listen, make sure it sounds good, and this should be a quick conclusion to our part 4. So I'll see you guys in a little bit. Okay guys, we're done. We've got everything put together, everything soldered in place. Haven't tested anything yet. That's what you guys are going to be coming along for. But let's put all these wires back up inside here. Make sure everything goes in. See, we got a wire stuck over here. Let's get those up and inside. There we go. Come on. There we go. Now, normally I would make these a little shorter, but in the essence of time, rather than cutting and trimming them every time, I just went ahead and put them in. But you can make the wires shorter so there's not quite as many having to worry about coming out. So now we're going to grab our, whoops, wrong package of couplers. Here we go. Oh, we've got these McHenrys. We're going to trade these out for some KD number 148 scale knuckles. Oops, that's upside down. There we go. So we've got our coupler switched out, and we just simply slide it in place. And we're going to do the same thing on the other side. Okay, there they go on the rear. And we just slide it into place. And then we can come in, take our screws, and oops, there we go. We're going to put them into place just like that. Now, I haven't done any testing honestly on this. Just kind of put it together, did all the testing during the assembly. So there we go. So these little trays are great that you get them with food, either like at the restaurants or something like that, or if you get takeout, they're great for storing parts. So there's our mostly finished model. Now we're going to grab our track power. Uh-oh, what's going on over here? Ah, I see what's going on. Okay. All right. I had the brake line come around. too many projects on the workbench here. All right, so over in the corner, I've got myself a DC power supply. And we're going to go ahead and power it up. And you can hear it's powered up. Everything's good. So let's go ahead and check everything. We've got our headlights on. Go ahead and go to our FX3. You can see that our front class lights are both on. FX4, our rear class lights are on. FX5, the front number boards are on. FX6, the rear number boards are on. So now we're going to just go through and make all the lighting settings the way we want them to be, and then we can button this thing up. So first thing I usually do, I'll go in and set my master volume. We're going to set this down quite a bit. I usually go about 100, mostly because what I want to do is make sure that we're not too loud. Go into our main sounds here. We're going to set our prime mover to the 645 turbo. And take the volume for that down to about 120. I'll make it 100. We're going to take our pitch and we're going to shift it down a little bit. Change our RPM increase every 15 speed steps. Air horn here, we're going to make the RS3L or the S, where'd it go? There it is, RS3L. And we can sample it. So we're going to take our horn volume down to about 100 also. And then we can sample it. In here it's quite a bit quieter. Our bell, that's probably fine, but let's go ahead and reduce our volume down pretty low, and that should be fine. Air compressor shaft driven. Poppet valve, we want to make sure it is an actual poppet valve versus the air dryer. Oh wait, we can turn off the bell because we're not selling ice cream. And you can go in here, steam generator, I'm going to take that, set it to 0 because there's not a steam generator on here. And you can work your way through the rest of these other sounds, volume settings, brakes, rate settings, everything like that. This is just a really quick to show you how fast and easy it is. We're going to rename this locomotive here. We're going to go ahead and call it the MOPAC SD40, number 3041. Enter. And then we're going to go ahead and change the address to 3041. We're going to hit apply, and you're going to see that it automatically changed it to the extended long address. And then this is where we're going to go into our headlight settings, our different light settings. We're going to make sure this is known as an LED. Same thing with the backup light here. We're going to set that up for LED. And you can work your way through. So my FX3, what we want to do is we want to set this up for an on-off brightness 1. Change this to LED. And then we want to make sure that these are enabled in both directions. There we go. And what we can do now is we're going to go back. We're going to turn on the FX3 light, and you can see that it's already dimmer than it was. But we can go in here to brightness, and the brightness 1 right here you can see is set to 153. We can set this to 100, and you can see that it got a little dimmer. We'll change this down to like 75, and that's probably a good brilliance right there. And then same with brightness 2, but we're going to go back to different light settings. So the FX5, which is our front number boards, we're going to set this as the brightness 2. Again, we want to make sure that it's a LED. Yes for forward, yes for reverse. And then we're going to go ahead and turn it on. So we can see that our light is a little dimmer. And we can go in here again to our light settings. And brightness, this is brightness 2. We can adjust this down to 100, and you can see that it got a little dimmer. And you can just play with this as you go to determine how your lights work. So this is a quick little short tutorial on how you set up your Locomotive once you get the Blunami installed. So certainly can play in with all the settings and adjustments that you have in your app, and make the decoder perform the way you want it. So with that, I think we're going to go ahead and call it a episode. 3041 is ready for the rails. So stay tuned as we work on episode 5, where I'll show you some basic weathering techniques to really make it look like it's been used, and so that it takes away that new car smell. So thanks for watching. Hope this has been informative for you. If you like this type of content, be sure to like below and subscribe to our channel so we can know what type of content you're looking for, so that we can do more projects like this, and show you more about how to work with the decoders and working with the models that you have. So anyway, with that, thanks for watching. We'll see you next time.